You can now watch my videos in Hindi also. Go to the specific video, click on settings, next click on audio tracks and then change the language settings from English to Hindi. Hello students, welcome back. So in today's video, we'll not be solving any question, rather we'll be understanding what Snell's law is. Many times students have asked me to make a video on Snell's law, so here's the video. So let's start and understand what Snell's law is. Now before going to Snell's law, let's first know what are the laws of refraction of light. When light travels from one medium to another, it undergoes bending known as refraction. The refraction of light takes place according to two laws which are known as the laws of refraction of light. So let's see what these laws are. According to the first law of refraction of light, the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. For example, in the figure below, AO is the incident ray, OB is the refracted ray and N dash is the normal. They all lie in the same plane. That is the plane of paper here. So if you look at this plane of paper, you will find the incident ray, you will find the refracted ray and you will find the normal all in this plane of paper only. So this is the first law of refraction. Now let's go to the second law. The second law of refraction gives a relationship between the angle of incidence and the angle of refraction. This relationship was discovered by Snell experimentally in 1621. So the second law of refraction is also known as the Snell's law of refraction. So now what is Snell's law? Now according to Snell's law of refraction of light, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. That is, if you take any pair of media, whether it is air, glass or air, water, sine I by sine R will always be a constant. That is, let's look at this diagram here. If this is the angle of incidence I and this is the angle of refraction R, let us assume that this is air medium and this is glass medium. Now, light is incidenting at the interface of the air and glass medium with some angle I. And after it enters the glass medium, since glass is a denser medium in comparison to air, so the ray will bend towards the normal and it goes in this way. Now it forms an angle which is known as the angle of refraction. Now if we find out the sine of this angle of incidence and then divide it with the sine of this angle of refraction R, we will get a constant value always. And this constant value will remain same for this air and glass pair of media irrespective of the angle of incidence. That is, for this two pair of media, air and glass, if light is incident at any angle in the interface of this air glass medium, then the sine of this angle of incidence will give a particular value. Now, as per that angle of incidence, we will get a particular value of angle of refraction. Now divide sine I by sine R, we will get a constant value always. If I value changes, R value also will change. But the value of sine I by sine R will always remain a constant for this given pair of media, whatever be the angle of incidence is. Similarly, if we consider that this first medium is air and the second medium is water, then the sine of angle of incidence divided by the sine of angle of refraction in water, then the sine of angle of incidence of light in air divided by the sine of angle of refraction in water will again always be a constant value irrespective of the angle of incidence, because with the change of angle of incidence the value of angle of refraction also will change. But if we divide the sine of this value of angle of incidence corresponding to the sine of this value of angle of refraction, that value will always give us one single value only. And this constant is known as the refractive index of the second medium with respect to the first medium. So this is the explanation of Snell's law. So we can write this as the sine of angle of incidence divided by the sine of angle of refraction is equal to sine I by sine R, which is a constant. This constant is known as the refractive index. Suppose a ray of light traveling in air enters into another medium and gets refracted. Let the angle of incidence in air be I and the angle of refraction in that medium be R. So this is the figure which we can refer to. The value of sin I by sin R for a ray of light passing from air to a particular medium is called the refractive index of that medium. That means the medium to which light is entering or going. So the refractive index is usually denoted by the symbol N. In some places you will find it written like this, mu, mu. So the refractive index N21. So it is written as a subscript N21. That is the refractive index of the second medium with respect to the first medium is written as sin I by sin R. Sin I is the angle of incidence in air, whereas sin R is the sign of the angle of refraction in the given medium, that is the medium to which light is entering. And N21 is the refractive index of the second medium with respect to the first medium. It is written as a subscript N21. So I hope you have understood Snell's law. Now let's solve a numerical using this formula, which will help you to understand this formula better. So the question is, light enters glass from air. The angle of incidence is 30 degree. The angle of refraction is 19 degree. Find the refractive index of glass. So alright, so here we have been given a glass slab and light is incidenting on this glass slab and the angle of incidence is given as 30 degree, and we know that this air is a rarer medium and glass is a denser medium. So when light ray enters from rarer to a denser medium, it will bend towards the normal. So this is the refracted ray, and this angle of incidence is given over here is 30 degree, whereas this is the angle of refraction which is given as 19 degree. So now we have to find out the refractive index of this glass. Now we know the formula. Refractive index of glass with respect to air is sin I by sin R, which is sine of 30 degree divided by sine of 19 degree. Now we know the value of sine 30 is 1 by 2 or it is 0.5, whereas sine 19 degree is 0.325. So upon calculation we get the value approximately as 1.54. So the refractive index of glass with respect to air, which is N21, is 1.54. So this is the value of the refractive index of glass. So in this way, using Snell's law, we can find out the refractive index of glass. Now that we have solved this question, let's understand what absolute refractive index is. So when light travels from one medium to another, its speed changes, causing it to bend. So when light changes medium, its speed changes when it enters a new medium, and that's the reason why light starts to bend in a new medium. So to measure how much the speed of light changes inside a medium compared to air or vacuum, we use a quantity called the refractive index. The special case where first is vacuum or air is called absolute refractive index. So when light enters any medium from air, so if the first medium is air, the second medium could be anything. It could be glass, it could be oil, it could be water. But if the first medium from which light is coming is air and then entering any other medium, then the refractive index of this medium in comparison to air will be called as absolute refractive index. But if light is coming from some other medium, let's say this medium is water and this medium is glass. So if light is coming from water to glass, then the refractive index of glass with respect to water will not be called as absolute refractive index of glass with respect to water. So absolute refractive index is considered only and only when the first medium is air. So I hope you are clear with this. Now let's proceed to the definition. The absolute refractive index of a medium is the ratio of the speed of light in vacuum or air to the speed of light in that medium. So the formula is N is equal to C by V, where N is the absolute refractive index of the medium. C is the speed of light in vacuum, that is 3 into 10 to the power 8 meter per second. So light has the highest speed in vacuum and V is the speed of light in the given medium. Now let's understand the easier explanation of this, that light slows down when it enters a denser medium. Therefore, the speed of light in the second medium is less than that of the speed of light in vacuum or air. So the refractive index will be more than 1, because you see here N is equal to C by V. Now if this value is less, then the value of C will be more. So the value of the refractive index N will be greater than 1. Now, the higher the refractive index of any medium, the slower will be the speed of light in that medium, and thus the medium will be optically more denser. So, I hope you have understood what is absolute refractive index. So, absolute refractive index tells us how many times light slows down in a given medium compared to air or vacuum. So, N is equal to speed of light in air or vacuum. Normally, we denote it with the symbol C divided by the speed of light in the given medium, that is V. So, N is equal to C by V. Now, let's understand this with an example. The speed of light in air is given as 3 into 10 to the power 8 meter per second. But when this light enters glass, its speed reduces to 2 into 10 to the power 8 meter per second. That is, it slows down and it bends towards the normal because glass is an optically denser medium. So, refractive index of glass is speed of light in air or vacuum using this formula by speed of light in the medium. Here it is glass. So, that is 3 into 10 to the power 8 divided by 2 into 10 to the power 8, which value comes to be 1.5. It means that the speed of light in air by speed of light in glass is 1.5, which means that speed of light in air is equal to 1.5 times the speed of light in glass. That is, the value of the speed of light in glass multiplied by 1.5 will be equal to the speed of light in air or vacuum. So, the speed of light in air is 1.5 times more than the speed of light in glass, or we can say that light travels 1.5 times slower in glass than in air. So, for this V air, we write C is equal to 1.5 Vg. So, I hope you have understood this formula now. Now, if our medium 1 is anything other than air, so how can we rewrite this formula? That is, suppose light is traveling from water to glass. That is, this medium is water and this is glass. So, how can we rewrite this formula? Now, let light be traveling in the first medium with velocity v1, and when it enters the second medium, its velocity is v2. So, we can rewrite this formula as refractive index of the second medium with respect to the first medium is speed of light in medium 1 divided by the speed of light in medium 2, that is v1 by v2. Or we can write N is equal to v1 by v2, where v1 is the speed of light in medium 1 by the speed of light in medium 2. Now let's go on to solve a question. So now if we know the speed of light in any medium, we can find out the refractive index of that medium. Let's see how. So speed of light in water is 2.25 into 10 to the power 8 meter per second. It's given. Find out the refractive index of water. Now we know the refractive index of water with respect to air is the speed of light in vacuum by the speed of light in water. Now we know the speed of light in vacuum is 3 into 10 to the power 8 meter per second. The value of velocity of light in water is given as 2.25 into 10 to the power 8 meter per second. So this cancels. So it is 3 by 2.25, which is 1.33. Hence the absolute refractive index of water, NWA, which is sometimes written as NW only, is 1.33. So this is the way in which we can find out the refractive index of the medium if we know the speed of light in that medium. So now let's summarize what all we have learned. Today we have read about Snell's law, which is sine of angle of incidence by sine of angle of refraction is a constant and is known as the refractive index of that medium. Refractive index of a medium can also be found out if we know the speed of light in the given medium. By the formula, refractive index is the speed of light in air or vacuum divided by the speed of light in the given medium, that is equal to C by V. And this formula is applicable when light is traveling from air or vacuum to a given medium. But if light is entering from one medium to another where the first medium is not air, then this formula can be written as refractive index of the second medium is equal to speed of light in medium 1 divided by the speed of light in medium 2, that is V1 by V2, where V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2. So this is all about Snell's law. So I hope I have been able to solve your queries regarding Snell's law. If you have any other doubts, please feel free to ask me in the comment box. But before you go, let me request you all, please go through the playlist containing the solved physics question and answers from the previous year's board exam, which will be very helpful to you during your exam preparation. So that's all for in this video. Thanks for watching.